Hey everybody, hey, it's after Easter break. I want to let you know Karen cut my hair, so that's great. I didn't have to worry about that. And so let's go ahead and get into our next chapter, chapter 9. So on chapter 9, we're going to be talking about heat, which is going to be simpler, so I'm happy to say. So let's look at our ISM book. So for heat, the concepts that we're learning is the concepts of temperature, internal energy, thermal equilibrium, identifying Kelvin, Fahrenheit, Celsius, and temperature scale. We've already done Kelvin, Celsius, and Fahrenheit when we did chemistry, so this should be very like a review for you. Temperature is proportional to the kinetic energy of an atom and molecule. Molecules can rotate or vibrate. Internal energy, which is proportional to the substance temperature, assuming there's no phase change. You have transitional, rotational, and vibrational, and it gave you some examples in the book. It also talked about thermal energy is a state which two bodies in physical contact with each other become identical. It was talking about a can, and when it's cold on the inside, and then you put your hand on it, you go outside, and it warms up. That has to do with thermal equilibrium. Thermal equilibrium is based on the measure of temperature of a thermometer. Matter expands as its temperature goes up. Thermal expansion can be in a solid, liquid, or a gas due to the increasing temperature. They use what's called the coefficient of the volume expansion, thermal expansion characteristics of material. Gases are larger, liquids are smaller. When you're measuring temperature, you have to calibrate your thermometer requiring a fixed temperature. And then you have these two formulas here. And these two formulas are the ones that you're going to be using to be either converting Celsius to Fahrenheit or Celsius to Kelvin or vice versa. And so first of all, on page number 305, it gives us an example. The example on 305 says that what is the equivalent Celsius and Kelvin temperature of 72 degrees Fahrenheit? So the first thing that we want to do is make sure that we have our calculator to normal and to radian, which we do. So it gave us 72 degrees Fahrenheit, so then we're going to try to convert them to Celsius and Kelvin. So what we're going to do first is to be able to convert it to Celsius, we're going to do alpha y enter, and that is 5 over 9 over, open bracket, 72, subtract 32, close bracket, and then enter, and that's going to give us, whoops, sorry, did something wrong here. I didn't put a point on here. Then we get 22 degrees Celsius. So then the next thing that we're going to do, we're going to go ahead and convert it to Kelvin. So to be able to do that, we're going to take our 22.2, which is our Celsius temperature, and add 273.15 to it, and that gives us 295.4, which I got 35. Okay, so that's what we do in there. So let's look at the first problem. It says the lowest outdoor temperature ever recorded on Earth was a negative 128.6 degrees Fahrenheit, recorded at, and it says the temperature on Celsius and Kelvin scale. So to be able to do that, the first thing that we want to do is we want to go through and find Celsius first. So we're going to do alpha y enter. That would be 5 over 9. Open bracket, our temperature F, which is a negative 128.6, and we're going to subtract that by our 32, close our bracket, and we get a negative 89.22. Then what we're going to do is then we can convert it to Kelvin. We're going to take this answer here, and we're going to add 273.15 to it, and that gives us 183.93. Number 2 is a little different, though. It says, in January 21st, 1918, North Dakota had a surprising change in temperature. Within a 12-hour period, the temperature changed from 237 to 283. What is the change in temperature in Kelvin and Celsius? So the first thing that we need to do is we need to first of all find the change in temperature. So we're going to take 283 from 273. 273. And we're going to get 46. Sorry, I made a mistake here. After we get that, then we're going to plug it into our formula here, which our formula here is 9/5, and we're going to multiply that here by our 46, which is our change in temperature, to get our Fahrenheit. Okay? And then also to get our Celsius, we've already got that. So there's our first answer, and there's our second. Number 3. Number 3 says a normal human body is 86 degrees Fahrenheit. A person with a fever records at 102 degrees Fahrenheit. Express the temperature in Celsius. So the only thing we have to do here is we have to take our 5/9 again. So that's alpha y enter 5/9, and then open bracket. We're going to do our 102, which is our temperature final, and we're going to subtract that by our temperature initial, which is 98, which is 32. To get our Celsius. Close bracket, and that is going to give me an answer. And then I'm going to do 350 divided by 9. It gives me my 38.88, which I rounded up to 39. Okay, so then number 4 basically asks us a pan of oil is heated to 23 to 78. What is the change in temperature in Kelvin and Fahrenheit? So the first thing we're going to do is we're going to take our 23 and we're going to add it to our 273, 15, which we get 296. Then we're going to go and take our 78 and add it to 275.15 to get 351. We have to get those numbers first in Kelvin so that we can do the rest of the equation. So we're going to take our 251 and subtract it from our 296, which is going to give us 55 degrees Kelvin. And the only thing we're going to do there is we're going to actually convert it to Fahrenheit, 9/5, 78 minus 23, which would be 99. And then number 5, some volcano lava in Hawaii reaches high temperatures, express the temperature of 2,192 degrees Fahrenheit into degrees Celsius. So we're just going to do 5/9 times 2,192 minus 32, which we're going to get 1.08. So let's do that. Alpha y enter 5/9, open bracket, 2,192, subtract 32, close bracket, enter, and we get 1,200 is the answer. But if we want to, since it's a very big number, we can also change it to scientific, and either one of them are acceptable. And that's where I get 1.00 times 10 to the 10th to the 3rd power. That's my page number. Okay, so I graded your test. Gave you your grade, and then I also sent you the answers to it so that you can make changes to it. Please continue to stay on task. As you can tell, ISM book is very important. As you can tell, everything of all my notes are in here. And what I'm doing this for is I'm planning on using this again next year. But then also, you could use it again if you're taking physics in college. I hope you had a really good Easter weekend. If you could share with me in a comment to let me know that what you did. I'm interested to see what you've done over Easter break, I did some house things that needed to be done. It was desperately needed. I went and saw my daughter, and 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 I also spent time with Paisley, which I had really enjoyed being in Greenville for a couple of days. I also had KK over. KK and I did Easter egg hunt. We colored eggs, which I'll have to give you a picture of those. And maybe I'll bring them in here so that you can see them tomorrow. And we made Rice Krispie treats. We did a scientific investigation on Rice Krispie treats. We were trying to figure out if there's a difference between frosted Rice Krispies and regular Rice Krispies. And we found out that the frosted Rice Krispies are very, very, very sweet if you like really sweet Rice Krispie treats. And then also we decorated cookies. So I've had a fun-filled Easter. And as I can tell, some of you are putting on your prom dresses, going out and taking some pictures. And by the way, you look beautiful. I'm hoping that we'll be able to get back before the 15th of next month. We've got about 30 days that you pretty much have left. It's 4/20 now, so you have less than 30 days to finish. If you'll please just keep up with your schoolwork, and I want to let you know I love you and I miss you. Have a good day.